Good afternoon, class. Today's experiment, we shall be using the Hamdan heat conduction demonstrator. And from this equipment, we'll be doing experiment 1, which will be heat conduction through constant and variable area copper cylinders. What we shall be doing today, we shall be evaluating the thermal conductivity through a tapered and straight cylinder at various flow rates, which we will control from our rotometer. The temperature shall be applied from the heaters number 1 and number 2, and the flow rate shall be controlled by the rotometer so that we can maintain a heat sink. That is done so by having cold water coming in and exiting here for both cylinders. And now this cold water is cycled through the system and the process keeps going on and on. Now, throughout each cylinder, we have thermocouples at 1 inch intervals going all the way through. So each cylinder would comprise of 10 thermocouples. So we would have 10 thermocouples on the tapered cylinder and 10 thermocouples on the straight cylinder. Now these thermocouples, we would pick the readings up from the control panel here. Now switch 1 would give us our readings for heater number 1, which would be 22 on the panel, and 23 would be heater number 2 on the panel. Now to get to the thermocouple readings, we go to 24 and then go down to switch number 2. On switch number 2, we can cycle from 1 through to 24, which would give us our readings. So what we'd have 10 on each cylinder, which would be 20, and then we would have 1 on the inlet and the outlet, which would be 22, and 1 on the inlet and the outlet, which comprises of 24 different readings. So hence we would get 10 readings through the tapered and 10 readings through the straight, and we would get our in and out on the tapered and in and out on the straight. And in this experiment, we'll be doing the experiment 3 times. So we're going to run our first experiment at 30 gallons per hour. Then we'd go over to our system, allow it to stabilize roughly 10 minutes. Then we'd take our readings for both heaters and all thermocouple readings. Then we would adjust our flow rate from the rotometer to 20, allow it to stabilize, and repeat the reading process. And finally, we'll take it down to 10 gallons per hour and do our readings again. From there, the experiment would be complete. So at this point, I'm going to turn the machine on. It's a little bit noisy, and then we'll allow it to stabilize and run the experiment. Thank you. Okay guys, so now we're going to actually start the experiment. And what we have here, we have rotometer number 1 set to 30 gallons per hour, and rotometer number 2 set to 30 gallons per hour. So rotometer 1 goes through heater number 1, and rotometer 2 goes through heater number 2. Now, as you can see on heater plate number 1, the cylinder on top is of a tapered shape, and on cylinder number 2 is of a straight uniform configuration. Now, in each cylinder, we have thermocouples placed at 1 inch interval going through. So basically we have 10 thermocouples in this cylinder and 10 on this one. So from here we will go over to this dial to switch number 1, and on switch number 1 we would read the temperature across plate number 1, which is 239, and across plate number 2 is 210. And then we go down to switch number 2, where we would read the actual thermocouple readings through. So let's start with 1. So at 1, it's at 141, 2, 136.3, 132.9, 129.6, 126.1, 122.5, 119.3, 116.4, 112.3, 108.5, 141.4, 133.4, 127.7, 122.6, 118, 114.2, 111, 108.5, 105.8, 103.5, 97.5, 97.6, 97.7, and lastly, 98.7. What we would do to continue with the experiment is to adjust our flow readings to 20 gallons on both rotometer 1 and 2, allow the system to stabilize, then we would take readings all over again, heater reading and all the thermocouple readings, and then we would adjust down to 10 gallons per hour and do the same process all over again. And just to make it clear, what we have here, we have our cylinder, and as you can see, there's thermocouples numbering from 1, 3, 4 all the way through to 20, and these would be actually within the cylinders, both the tapered and the straight. So with that concludes the experiment. You'll be getting your readings and datas from Dr. Whitworth. Thank you.